Using calculus and algebra, determine the coordinates and nature of any stationary points on the graph. F of x is 9x squared minus x cubed minus 15x plus 11. So we're going to need f dashed x, and that's going to give me 18x minus 3x squared take away 15. Now for stationary points we want f dashed x is equal to 0. So that means that negative 3x squared plus 18x minus 15 equals 0. Now all of these divide by 3. I'm going to divide through by negative 3, and that gives me x squared minus 6x plus 5 is equal to 0. So we can factorize this one. X and x, 5 and 1, and 2 minuses. So we've got that x is equal to 5, or x is equal to 1. So if x is 5, then f of 5, to find the y coordinate, is going to be 9 times 25. Take away 125. Take away 15 times 5. Add 11. So that gives us 36. So y is 36. Now if x is 1, then we just get 9. Take away 1. Take away 15. Add 11. And that gives us 4. So our turning points are at 5, 36, and at 1, 4. So we need to know the nature of these. So let's do 1 first, and then 0 and 2. All we need to do is make sure we don't go past the other turning point, but that's at 5, so that's fine. So we know it's 0 here. And if we substitute 0 into here, we get negative 15, so that's negative. Put 2 in, and let's have a look. So we've got 18 times 2, take away 3 times 4, take away 15, it's 9, so that one is positive. Down, across, up, so that one there must be a minimum. And then if we do 5, we may as well use 2 as the one to the left since we've already done that. We'll go for 6, so dy dx. So this is 0, we already know this one is positive. And if we do the 6, we get 18 times 6, take away 3 times 36, take away 15, that one is negative. So up, across, down, so that's a max. So this one here is a max, and this one here is a min. We now want the x and y intercepts for the function. So the y-intercept that's when x is equal to 0. So that would give me y equals 11. So we've got 0, 11. And for the x-intercepts, that means that y is equal to 0. So that would give me 9x squared minus x cubed minus 15x plus 11 is equal to 0. Now we could go through the whole factor theorem type process with this one, but that's not really going to help us understand what we're doing here. So I'm just going to solve it. So action, advanced, solve, and we want 9x squared minus x cubed, take away 15x, add 11 is equal to 0. And perhaps we should have gone for decimal here. It just shows that if we'd gone through the whole process, we may well not have found a solution anyway. So it looks like there is only the one solution, which is when x is 7 point, let's call it 11 to 2dp. So that would be 7.110. Now the behavior as x tends to positive or negative infinity, note that the leading term is negative x cubed. Now as x tends to positive infinity, x cubed will be positive, so negative x cubed will be negative, so y is going to tend to negative infinity. As x tends to negative infinity, so the x cubed will be negative, negative negative is a positive, so y will tend to infinity. So we want to sketch the function. So let's look what we've got. We know that we have a minimum at 1, 4. So that's there. And a maximum of 5, 36. And the only intercept, x-intercept, is at 7, 11. 7.11, sorry. And then we have the y-intercept at 0, 11. And as x tends to negative infinity, y tends to infinity. So it's going to come down like this. It's going to take its minimum here, come up, take the maximum up here, and then come down through this intercept like so. So this is y is equal to 9x squared minus x cubed minus 15x plus 11. So this is 11. Let's just put these points on that we know. This one is 1, 4. This one is 5, 36. And this one is 7.11. We now want to determine the maximum value of the function in these two domains. So 0 to 7, well, 0 to 7 is sort of here to here, and we can see the highest point between those is at this maximum point. So for part 1, we can say that 36 is the maximum value of the function. Now for part 2, we need to expand the domain outwards, so we're expanding outwards across here to negative 2 to 7. So we need to know how high the function is at negative 2. So we're going to do 9 times negative 2 squared. Take away, we need to make sure we're out of the template, so take away negative 2 cubed, take away 15 times negative 2, add 11. That gives us 85, so it would be higher than the maximum here. So 85. Let's go back to the blue pen. So 85.